Question 9. The sketch below shows the graph of y is equals to f prime of x. So is the derivative of a cubic function gives you a parabola. The turning point of f prime is 1 and 2, and the y-intercept is 0 and 3. So we are given the diagram below. So 9.1 says that for which values of x is f increasing. So they're talking of a cubic function, not necessarily this parabola. So what we need to note is, since this parabola is a smiley face, it means that our cubic function increases, decreases, and increases, right? So we want to identify the values of x when our cubic function increases. So how are we going to determine that? We're having the turning point of this function here at 1 and 2. So and we also have the intercept. So this is the intercept. So the intercept of our parabola is actually the turning point of our cubic function, but I'm only talking of the x value of this graph here, not necessarily the y value. So for this answer for 9.1, you can simply say that the graph of f increases. X is the element of real numbers. So meaning that if you look at this side here, the graph of a cubic function is increasing from a negative infinity up until this point of the turning point. And also from here, the graph of a cubic function is increasing from this turning point all the way up to a positive infinity. Hence, I'm saying the graph of f increases from negative infinity to positive infinity, excluding this middle point between the turning point of this part and the turning point of this part. So hence you can simply write this as your solution for 9.1. So your answer can simply be x is the element of real numbers, or you can simply write from negative infinity to positive infinity, right? Or since if you're having a parabola, so 9.2, what is the gradient of the tangent to f at x is equals to 1? So what we need to note is that the derivative of a cubic function gives you a parabola, which is going to, so the derivative of a cubic function gives us a parabola, which helps us to identify the gradient of a tangent. So for us to identify the tangent at x is equals to 1, we have the turning point and a point for the parabola. So we can simply find the equation of this parabola here. So what we can do is this: we can simply write f prime of x is equals to a into x plus minus p squared plus minus q. So our turning point is given as 1 and 2 from the diagram, and we have a point which is at 0 and 3. We also know that the tangent the x value of the tangent is equals to 1. So to write this equation, we can simply say f prime of x is equals to a into x. So the x value of the turning point is 1, as I've indicated, so we're going to write minus 1 there squared, and the y value of the turning point is 2, so we're going to say plus 2. So we're going to substitute the point or the intercept of 0 and 3, and we're going to write 3 here is equals to a into 0 minus 1 squared plus 2. Then we're going to find the value of a so that we'll be able to identify the equation of the parabola, then be able to find the gradient of the tangent. So it's going to be 3 is equals to 0 minus 1 is going to be a into minus 1 squared plus 2, which is 3 is equals to a plus 2. Transpose the 2 to the other side, we have a equals to 3 minus 2, which is equals to 1. So your a is equals to 1. Then your f prime of x is equals to 1 into x minus 1 squared plus 2. But we know that the x value of the turning point is equals to 1. So we can substitute that value here. So we're going to have f prime of x of the tangent is equals to 1, which is equals to 1 into 1 minus 1 squared plus 2. So 1 minus 1 will give you 0. So meaning that you have 0 plus 2, which is equals to 2. So this is the gradient of your tangent. 9.3. Sketch the graph of f if it is given that f of 0 is equals to minus 2 and f of 1 over 2 is equals to 0. Label all the x and y intercepts, stationary points, and points of inflection, if any. So we are told that f of we are told that f of 0 is equals to minus 2. So this is the so this is the y-intercept, and then we're also told that f of 1 over 2 is equals to 0. So this is the x-intercept when y is equals to 0, right? So to draw our function, we're going to indicate the intercepts. Start with this one, which is 1 over 2 and 0, and then this one here, which is 0 and minus 2. So these are intercepts, and we know the turning point. Our turning point is minus 1 and 2. Oh, and our turning point, we know the y value is not defined for this graph, but we know that the x value of the turning point is equals to 1. So if this is half, then 1 can possibly be here. So the x value of the turning point is here, which is equals to 1. So let's say, for an example, we assume that the turning point is here, because we don't know the y value of the turning point. We don't have the original equation of f, hence we cannot define the y value of the turning point. So just going to indicate and say this is my turning point, and then if I were to draw the graph, the turning point, so meaning that the graph will face that direction, and then it will change and go down here. Let me do it nicely. So it's gonna go down there and look something like this. So this would be the turning point of 1 and y, because we don't know the y value of the turning point. So this would be my graph of f. Thank you so much for watching. If you have any questions, suggestions, or comments, please write them in the comment section below. Don't forget to subscribe to the channel for more videos.